Once again, I welcome you to this channel. Thank you for choosing us. Thank you for subscribing. Thank you for watching this video. My humble appeal to you is that make sure you follow all the lessons in their order so that you can understand very well every step. Don't forget to subscribe in order to get the notification. I still remain Alira Daniel, your one and only teacher, handling you physics and mathematics. Today we are discussing linear motion. We are going to discuss linear motion as our heading says. Before we talk about linear motion, we need to understand what a motion is. When you say motion, what does it mean? What comes into your mind when somebody says motion? So by definition, motion is just like we can define motion as change in the position. Change in the position in a given time. So if I move from A, if at a particular point I'm at A, and then another point I'm at B, then somebody is free to say that I've moved from A to B. Motion has taken place. That's what we're going to be motion. Now, the issue is, when you're talking about motion, we have what's going to be linear motion. Yes. How do we define linear motion? Linear motion is the type of motion that takes place in a straight line. Oh my God. So that means that we have also motions which take place in what? If it's a straight line, then it is what? Bent or curved line. Can a curve be? Yes, true. So linear motion is the type of motion which takes place in a straight line. We have those which do not take place in a straight line, like circular motion. Okay? Circular motion does not take place in a straight line. So what we are discussing here is strictly the motion which takes place in a straight line. So we have seen motion. We are saying motion is the change in the position of a body with time. If a body is at A, then after sometimes it's at B, then you say that the body has moved. That is linear motion. Now, there are some of the terms which you need to understand when you're dealing with linear motion. There are some terms which you need to understand when we are dealing with linear motion. So we can call them terms. And the first term is what we call to be distance. Oh my God. I used to say that distance is a distance. I say distance is the distance moved. That's the definition. Now what do you expect somebody to say as the definition of distance? If I may ask you, what is distance anyway? What is coming to your mind? Are you not saying that distance is the distance moved? So when you talk about distance, distance is the length between 2 points. If I have point A and point B, then the length between those 2 points is also going to be the distance between the between the 2 points. So you say that is the length between 2 points. This is what we call to be the distance. Note the distance moved, okay? It's the length between 2 points. It's measured in meters. It's measured in meters. As you are well aware of other units of distance, the other units of length, we have kilometers, centimeters, decameter, hectometer, and so forth. There are very many, of course. But we are saying the standard unit is what? Is meters. And distance is what we call to be a scalar quantity. Scalar quantity. Oh, way back we saw physical quantities. We said a physical quantity is that one which can be measured. Anything which can be measured is what called to be physical quantity. And we said they can be categorized into two. One, scalar, two, vector. Where we said a scalar quantity is that type of quantity which has only magnitude but no direction. That was our scalar quantity. Quantity with only magnitude but no direction. And those with both magnitude and direction, we gave it a name to be vector quantities. So distance has only magnitude without direction. So we say distance is a scalar quantity. What about the next term? The next term is called to be displacement. Sometimes like when I could hear the word displacement, I would say, that word is too big for me to pronounce it even. I would even fear to pronounce it. But when we talk about displacement, I'm going to use this illustration. Please stand up. Okay? Stand up. Then I'm going to tell you, please can you move 2 steps in front? Please can you move 2 steps in front? 1, 2. What about 2 steps backward? I'll move 1, 2 steps backward. Can you move 2 steps to the left? 1, 2. Can you move 2 steps to the right? 1 and 2. Okay? Then, can you move only 2 steps? Okay, oh my God. 2 steps, if I tell you, move 2 steps only, then you're free to take any direction. You can either take to the left, to the right, to the east, and even some people, they cannot even move. Because now you have told me to move 2 steps, so I move in which direction? So when I tell you 2 steps to the left, I've specified the direction in which you're supposed to move. And in that case, it is not just the distance moved, but it's a displacement. So we say that a displacement is the distance moved in a specific direction. Distance moved in a specified direction. That's what going to be displacement. Distance moved in a specified direction. So you're saying this is the distance moved in a specified direction. That is what we call to be displacement. It's also measured in meters. It is measured in meters. And the fact that we are saying 2 meters to the left, 2 meters to the east, 2 meters to the north and west and south. That means it has direction. And so it is a vector quantity. So we are saying it's a vector quantity. T. Oh my God. So I can ask you the differences between displacement and distance. There are 2 main differences here. The first difference comes in the definition. Is the length between 2 points, that is distance. And here is the distance moved in a specified direction. That's the definition. Then 2 is a scalar quantity. Here it's a vector quantity. So those are the main differences between displacement and distance. We shouldn't confuse the two. So the other terms are, let's discuss other terms. These are the first 2 terms which you need to understand when you're dealing with the linear motion. What are the other terms? The other terms are, we have term number 3, speed. I know now at the back of your mind you're saying speed is distance divided by time. Yes, you're not wrong, okay? You're very correct. Speed is distance divided by time. But in physics, we are a little bit unique. We say that if you divide anything by time, we call it to be rate. We don't say this is divided by time, ratio of distance to time. No, we don't have that, okay? It's the rate of this distance. So we define speed as the rate of change of distance. Rate of change of distance. That is what we call to be the speed. Mathematically, we can write this one as speed equals to distance divided by time. Speed equals to distance divided by time. That is what we call to be the speed. Distance is measured in meters, time is measured in seconds, and so the SI unit is meters per what? Meters per second. Distance is a scalar, time is a scalar, and so speed is a scalar quantity. Oh my God. Speed is a scalar quantity, is the rate of change of distance. I said rate means divided by time. That is term number 3. Speed has a sister. The sister to speed is called velocity. The sister of speed is called velocity. You saw distance had a brother. The brother to distance was displacement. And here we have speed with the sister, and the sister is velocity. So velocity, we say velocity is the rate of change of displacement. Speed is the rate of change of distance. Velocity is the rate of change of displacement. So this is the rate of change, of displacement. This is what we have as speed, rate of change of displacement. That is our speed. What is the formula then? Then our velocity is just change in velocity, is change in displacement. Then divided by time. So that's what you have as velocity. Of course, we are already aware that displacement is measured in meters, time is in seconds, so the unit is still meters per second, as just like that of speed. Displacement is a vector quantity, time is a scalar quantity, a vector divided by a scalar, you get a vector. So speed, velocity is a vector quantity. So much as they are sisters, but you can see there are some differences between them. The first difference comes in their definition. Here is the rate of change of distance, that is speed. Here is the rate of change of displacement. Speed is a scalar quantity, meanwhile velocity is a vector quantity, and so they can't be the same. Okay? So that is that when it comes to speed and the velocity. I can ask you, or somebody can ask you the differences between them. People tend to confuse speed and velocity. When they talk about speed, it is a scalar and rate of change of distance. And when they talk about velocity, it's a vector and the rate of change of displacement. That is that. Don't forget, we have other units for speed, kilometers per hour. So we are saying it is meters per second, but we also have kilometers per hour. Now the next one is the feet, and that is acceleration. That is term number 5, acceleration. Oh my God. For those of you who know how to drive, when you're driving, when you start on your engine, I also know to drive, but only I drive around my home. I don't go anywhere, okay? So I don't go any other place. I just drive around home. So when you're driving, you start the engine, put the gear, you press on the reins. That is the accelerator. Then you see the car move. So, like when you see on the speedometer, you see the speedometer going from 0 to 5, 5 to 10, 10 to 20, 20 to 30, 30 to 40. So when you see the speedometer going, increasing, that means that you are accelerating the car. That's what you mean by acceleration. So it has something to deal with the speed. It has something to deal with the velocity. Change in velocity. But also, you cannot start the car and then you start running at 80 kilometers per hour. No. Is it possible? Just within no minute, you are at 80. You start the engine, 80 kilometers per hour. That is not possible. So it takes some time, okay? So you have to first move. You move from 20 to 30 to 40 to 50 to 60 as time goes on. So it has some element to deal with what? With the time also. So we come and say that acceleration is the rate of change of velocity. Rate means divide by time. Change in velocity divide by time. That is our acceleration. So you're saying acceleration is the rate of change of velocity. Is a rate of change of velocity, i.e. acceleration A equals to change in velocity, then divided by time. Change in velocity divided by time. We have seen the unit of velocity is meters per second. Divided by time, which is second, so it gives us the acceleration as meters per second squared. This is the SI unit. I guess you can now tell me whether acceleration is a scalar or a vector. Is it a scalar or a vector? We have velocity, which is a vector. We have a time, which is a scalar. So, it's a vector quantity. So, we're saying acceleration is a vector quantity. So these are some of the terms which, when we understand them very well, we don't suffer a lot when we are dealing with the motion in a straight line. Any question, please type there in the chat box. I will reply, okay? Good. So, can we move on to something else? If there is any question, please type in the chat box. Okay, good. So let's see how to change the units of speed. We are saying speed can be measured in kilometers per hour or it can be measured in meters per second. So how do we convert from meters per second to kilometers per hour or kilometers per hour to meters per watt? To meters per second is what we are doing. So let's see how to convert from kilometers per hour to meters per second, the units. Conversion of units of speed, conversion of units of speed. So we are going to write a simple question here. Then we say, convert the following to meters per second. Convert the following to meters per second. Part A, 72 kilometers per hour. Let us first do this, then you go to the other second one. 72 kilometers per hour, we want it in meters per second. And we need to first interpret this very well. Okay? If I say 72 kilometers per hour, this one is the same as 72 kilometers, then per means divided by. This per, negative 1 means divided by. Divided by 1 hour. Per hour is 1 hour. So 72 kilometers per hour is like 72 kilometers divided by 1 hour. So if we want it in meters per second, then we have to convert 72 kilometers to meters. We have to convert 1 hour to seconds so that we can get meters per second. Good. 72 kilometers, we are converting it to meters. You know, 1 kilometer equals to 1,000 meters. Then what about 72 kilometers? That would be 72 times 1,000 kilometers, meters. So, I'll convert this. 72 kilometers is going to be 72 times 1,000. Now, in meters. So, this is in meters. Divided by 1 hour. How many seconds are there in 1 hour? Okay. I hear somebody is telling me 3,600. Very good. So it is 3,600 seconds. So when I do this is 72,000 divided by 3,600. So what do I get? 72,000 divided by 3,600, you can press on the calculator. 72,000 divided by 3,600. Yeah, when you press equals to, you see it's 20. So this is 20. So this is in meters per second. Therefore, this come and conclude 72 kilometers per hour is the same as 20 meters per second. As simple as that. Good. Let's look at number B. (108 kilometers per hour). So we are converting 108 kilometers per hour to meters per second. As we have already seen, that we need to first interpret 108 kilometers per hour. What does it mean? 108 kilometers per hour means that this is 108 kilometers divided by 1 hour. So, if I want it in meters per second, then we have to first convert this 108 kilometers to meters. You multiply by 1,000. You have to convert this 1 hour to seconds. So you multiply by 3,600. So you shall have 108 times 1,000. This is already in meters. Divided by 1 hour times 3,600. This is already in seconds. When I multiply 108 by 1,000, 108 times 1,000, I get 108,000. Divided by, this is 3,600. So what do we get? 108,000 divided by 3,600. I get 30 meters per second. So I come and conclude, therefore, 108 kilometers per hour is just 30 meters per second. So it's as simple as that. Now, I'm going to give you numbers to try. I'm going to give you some numbers to try. I'm giving you as a trial question. I'm giving you as a trial question. Make sure you try them out and you see how it's very simple. Okay, here is our exercise. Exercise number 1. Give 2 differences between one distance and displacement. Then part B, speed and velocity. Then number 2, convert the following to kilometers per minute to meters per second. Part A, 1080 kilometers per hour. Part B, 36 kilometers per hour. Then lastly, 144 kilometers per hour. Good. Let's try these exercises. Let's do them, and that will pave way for us in the next lesson. So in the next lesson, we are going to see uniform acceleration, uniform velocity with some calculations which are involved. Please endeavor not to miss the next lesson. As I started at the beginning, I told you don't miss any lesson for the flow of this. If you want the lessons to flow very well, please don't miss. If you have not subscribed to this channel, please tap on subscribe. After tapping on subscribe, you will always get notifications when lessons are posted. Thank you so much. I'm so humbled. I'm so glad for you for having watched this video. Goodbye for now. See you in the next lesson. Please don't forget to do the exercise. Don't forget to subscribe. Goodbye for now. Thank you. Thank you.